When it comes to timers in EIGRP, we have to recognize the fact that the configuration is different than a protocol like OSPF. In OSPF, we need to make sure that our timers actually agree between our neighbors before we can form adjacencies. EIGRP doesn't do that. In fact, we can form neighbor relationships between devices using EIGRP even if our timers do not match. Now, the main point that I want to illustrate here is that when we bring up neighbor relationships, what happens in the confines of EIGRP is a little different than any other routing protocol that we work with. EIGRP actually sends its timers in its update message or into its hello message, notifying the other device on the end of the link as to when or how to communicate to it. So the idea here is if I am R2, I'm going to communicate my timers to my neighbors, and my neighbor is going to use those timers to be able to communicate back to me. Now the idea here is again, these do not have to match. But what are the timers by default? Let's look at a show command that's going to allow me to be able to exhibit these timers very quickly. Show IP EIGRP interface detail, and what I want to do is I want to look at one of my two interfaces on R2. Here, I'll bring my topology back, and what we'll do is we'll look at this interface going down here. So that's going to be serial 2 0. So let's see here, we'll come up here and say on R2 detail serial 2/0. And what we see here is our hello interval. Our hello interval is every 5 seconds, and the hold down time is every 15 seconds. Now, when we recognize or we look at this, what this means is that I am telling my neighbor, R22 in this instance, I'm going to send my hello intervals at every 5 seconds, but I'm telling it to say if you don't receive a message from me within 15 seconds, consider there to be an issue with the routes that I'm advertising. So again, this information is being sent down this connection. Now what we can realize or work with here is the fact that we can do manipulations. We can change these timers. I mean, the main objective of studying for the CCIE Routing and Switching version 5 exam is to recognize the fact that we can use these timers to tweak our environments. Now, if I wanted to be able to do this, what I'm going to do is I'm going to do it on an interface by interface basis. So let's say interface serial 2/0. And what I'm going to do is I'm going to use the IP hello dash interval EIGRP, specify my autonomous system, and I'm going to give it how often I want to send these messages with regard to hello. So what I'm going to do is I'm going to come up here and say I want to send my hello every 10 seconds rather than every 5. I can also say IP hello dash, hold dash time EIGRP 10, and I could say 60 seconds. Now notice it didn't bring my peering down. Do show IP EIGRP neighbors. And let's take a look at this. Let's say end show IP interface, show IP EIGRP interface detail serial 2/0. Now when we look at this, notice it says my hello interval is every 10 seconds, my hold time is every 60 seconds. So we modified this particular behavior. Let's take a look at another interface. Let's take a look at Ethernet 03. Now notice it's using the default configuration here. So we can easily see that we can have different timers on different interfaces based on how we have things deployed. Now the other part of this is like I said, remember on the other end of our link, in this instance on R22, we have a mismatch. Let's take a look at that. So if I go over to R22 and take a look at show interface or show IP EIGRP interface detail for Ethernet serial 2/0, notice it's telling me that I have 5 and 15. So in other words, the configuration is different on each side of the link. Now, recognizing the fact that these messages are actually going to be sent, what I want to do is I want to take a look at the output of another show command. Let's say show IP EIGRP neighbors this time. Now what we're going to see here is notice that I have a hold down time here of 59 seconds and 10 seconds. Now this is going to be counting down or up. It's going to reset depending on how we have it set up. But the main thing here is remember I said that we were going to use a hold down time of 60 seconds on the link to R2, which is going to be that connection here to SE2/0. We know that the hold down time is 15 seconds here on the link to R3. And if we get lucky, we might be able to catch it refreshing. Got to 14, 10, okay, 14. So 15 is as high as this one's going to go. This one's going to go to as high as 59 seconds. Now the other point that I want to illustrate here is let's bring up a packet trace and take a look at the context of, or the content of what's happening. So what I'm going to do is, let's see, I'm going to try to grab a Wireshark session here. Let me see if I can't bring up a new one. To make this pretty, I'll just get rid of the drawing. And let's see what's going on here. Let me refresh and take a look at what's going on R2. And we will look at 03. No, actually, let's see, we changed that. So R22, 20. So let's take a look at what's going on 20 on R22, which is the interface pointing towards R2. All right, let's see if we can fire this up. All right, I want to look at EIGRP packets. And I'm not seeing any EIGRP packets. Did I grab the right one here? Just bear with me one moment. I'll grab another device here, another unit. Let's say R203. And we'll make a modification. Here we go. Now I got some traffic. EIGRP. And what we want to do is just look at some of these hellos. First and foremost, I'm just going to grab one. Notice this one's coming from R3 going to Cat 10. This one's coming from, I'm sorry, this one's R3 going to the multicast address. Here's R11, I'm sorry, Cat 1. Let's hit it. Go to EIGRP, and then what we're going to do is we're going to scroll down to the parameters field. And what we're going to see here is the fact that these are communicating the fact that we're going to use a hold down time, or a hold time of 15 seconds. Now this is, let's see here, this is going to be on R2 Fast Ethernet 03. So let's go to R2 Fast Ethernet 03 and see if we can't change this and see what's going to be communicated. So config T, interface, E03, I'm going to say IP, hello interval, EIGRP 10, and let's change it to 20 seconds, something that we should be able to see here. And what we'll do also is we'll do a hold dash time for EIGRP 10, and let's make it 80 seconds, something very conspicuous. Clear IP EIGRP neighbors. Show IP EIGRP neighbors. Let's see what's going on. I have my connection down to Cat 1 and my queue count is 0, so we should be good to go with that regard. Now let me see if I can't repeat this diagnostic here. Let's see. Can I refresh this and see if I can't pull anything else out? So let's see what's going on. Let's scroll all the way down to the bottom. And let's see. We want to look at the communication that's being shared. See, this is sourced from 11, so I probably should have changed it on the other side. Let's see what's going on. This one's 15. Okay, so here's what we'll do. I'm going to go to Cat 1, interface VLAN 210, do show run interface VLAN 210. And I'm going to change it here. I'm going to say IP hello interval EIGRP 10. We will say 20 seconds. IP hold time EIGRP 10, and we will make this one 70 seconds, just to pick an oddball value. All right, now let's see if I can refresh this. See, I don't know if it's actually refreshing. If I have to, I'll pull another trace. But let's see what's going on here. So right now we're looking at a value of, let's see, my number is 1089. Let's see if that number increments. Let's see if that's actually the case here. Scroll all the way down. 1089. It's not incrementing. So what I'm going to do is I'm going to redo this trace. Bear with me just one moment. And we want to look at R2, 3. And let's see what happens. EIGRP. Let's scroll down. All right, we've gone well past 1089. We're at 1359. So what I'm going to do is I'm just going to pick one of these. Let's see, that's coming from 11 to R2. So let's see what happens now with regard to our parameters. Notice the hold down time that's being communicated is still 15. So let's take a look at, let's see, which one is this? Let's take a look at this one, sourced from 3. See what it says. Am I on the right device? I'm on R2. Oh, okay, that's the peering over. In our topology, we have R2 and we have R3. And when I've went ahead and enabled the link between them as well as the links to R22. So what I'm trying to find here is I want to see how the different information is being communicated, or if the communication isn't being communicated. I want to see a odd value here, and there it is. Notice right now the hold time that's being sent is we're saying that we're going to use a hold down time of 80. Okay, sorry it took so long to find that, but the idea here is we need to understand that that's what's being communicated in all of this header information that's contained inside of our hello statements. So remember, what we're doing is we're telling our neighbor what our hold down time is based on the fact that, well, if we don't receive this particular amount of information, if you don't receive this from me within, or an update from me within this allotted period of time, we need to operate under the assumption that this link is down and not operational. Now, the other timers, we've entertained the idea of a hello interval and a hold dash timer. Those are going to be the values that are going to be part of that finite state machine. But there's another timer in the context of EIGRP we want to talk about, and that's going to be the SIA timer, the stuck and active timer. And in order to be able to envision or understand exactly how that's going to work, we want to make certain that we can first observe a condition, and that condition is going to be the fact that our device is going to try to go active on a prefix. Let's take a look at that in the next presentation. I'll see you guys there. Bye-bye.